Okay, folks, what we're going to do first with our next surface area video is we're going to do the surface area of a right regular pyramid. Okay, the surface area of a right regular pyramid. Okay, and so that formula is SA equals the area of the base, B, as always, plus 1/2 times the perimeter and times the slant height. Okay, and the slant height is basically what you want to call it is the altitude of the triangles that make up the pyramid. Okay, so for example, if we had this particular pyramid, this is a square pyramid, 12 by 12, 12 feet by 12 feet. And so we have a pyramid here. Okay. And suppose all of these little edges right here are 10 feet. Okay, all these edges are 10 feet. So the slant height, if we were to take one of these triangles out, so let's take one of these triangles and this one right here, and let's just take it out and look at it. Okay, so essentially what we have is a base of 12 feet, and each of these hypotenuses, or each of these legs in this case, would be 10 feet. Now, the slant height is the altitude of the triangle right here. This would be your slant height. Okay? So how are we going to get that? Well, we can use our Pythagorean theorem to get that, because look at what we have. We really have a right triangle here. And this would be 6 because it bisects this bottom part in half. So we could use our Pythagorean theorem. A squared plus B squared equals C squared. And so 6 would be my A, S would be my B, 10 would be my C. So really what I have here is 36 plus S squared equals 100. So subtract 36 from both sides and we get 64. And we get 64. Take the square root to find out what S is. And we have a slant height of 8 feet. So there's our S for our problem here. Now, I'll show you another example of how slant height can look here in just a moment. Okay, so let's go ahead and figure out what our base, the area of our base would be. Well, our base is a square, 12 by 12 square. So the area of that is 12 squared, side squared, remember, which is 144. Okay, 144. Now remember, surface area is going to be in square units, so this is going to be square feet in the end. This base would actually be square feet. Now what about perimeter? Now it's the perimeter of the base. So if we're looking at this base here, all these sides are going to be 12. So you're doing really 12 times 4, or 12 plus 12 plus 12 plus 12, which would give us a perimeter here of 48, which would give us a perimeter of 48. So what we have here is now we can go ahead and we can find the surface area. Okay, so surface area equals. Well, let me go back up here. This pen is a little tricky when you start writing at the bottom of the screen. Surface area equals, okay, 144 plus 1/2 times 48 times the slant height of 8. Okay, so half of 48 is 24. So 24 times 8 is 192. Okay, and 192 plus 144 gives us 336. And it's 336 what? Square feet. Square feet. And I know you can't see that very well, but square feet. So this would be how we go about finding the surface area of a right regular pyramid. Now, the only thing that's really going to differ with this, you might have a rectangle instead of a square base, but the chief difference in this is going to be how you're finding slant height, because slant height is very typically not going to be given. Okay, that is a typical thing for these kind of problems. So let me draw you another one here. Let's draw another one. And this particular pyramid, again, we're going to let it have a square base. Now we won't work this whole problem out because it's worked the same way, but I just want to show you the slant height portion. Alright, and in this particular pyramid, we have an altitude dropping down from the center, which is 40. Okay? Now, here's the most common mistake made with this. The most common error is that is the slant height when it's not. So, here's our altitude. If we were to draw a line out from the altitude to the outside wall, okay, so if we had a line, let's change colors here so you can see this more. So if we had a line here that went to the outside wall, how long would that line be? Well, assuming that altitude drops in the center, which it is, I know it doesn't look like it with my picture, but it does. If it drops into the center, then what it's doing is essentially dividing this in half. So since one side is 60, that means that would be 30. So we know that's 40. This would be 30. Now think about what this is, though. This slant, this is our slant height, remember, right here. That is also the slant of that triangle right there. That is also, this triangle here is the same thing as this one, okay? And this is actually the slant height of our outside triangle. If you were looking at the slant height like we did on the last problem, we're just looking at it at a different angle here, okay? But once you redraw it, you're going to get it the same way. You're going to still use your Pythagorean theorem. The only difference is now you know the two sides of the Pythagorean theorem instead, and so you can take that and take the square root of 40 squared plus 30 squared, and that's going to give you your slant height, okay, which for this particular problem would be 50. And there also a tidbit of information here, 30, 40, 50. That's called a Pythagorean triple, if you remember that from high school geometry. 30, 40, 50. Okay, so again, this triangle That right there is the slant height of the triangle that we're looking at from the outside. Okay, it's just a different way at looking at it. You're not looking at these two sides like we did before. You're looking at it more from a bisected view. Okay, from a bisected view. I hope that makes sense. That's just another way to find slant height, or another way I can give you slant height and you would have to find it. Okay, is if you have an altitude that drops down in the center. You have that, and then you have the way we did before, okay, where we're using the edges to find the slant height, okay. So this is the surface area of a right pyramid, okay. The next video will have a couple our last two surface area problems on them. Thank you.